Okay, so I've been having some trouble with the software that I use to record lectures. So we had a short video, unintentionally short, about vectors, where we just saw our first example of using vectors to hold doubles. So we actually just added comments to this program here, where we had our vector of doubles called temps. So if you haven't seen that video, definitely watch that one first because we're going to keep working with this program. But let's move on learning about vectors. So we saw the pushback method and we saw the size method. And here we can build ourselves a nice mental model of what actually is a vector. So we've got a size attribute that we can get using the size method. So here, as an example, maybe we have a vector that we've added 1, 4, 2, 3, and 5 to. So it has size 5. And then we have our integer array here that's actually holding those in order. So we already saw our temperatures vector holding doubles, but here we can visualize what it looks like when we call that pushback method. And I guess first when we declare our vector, so we could imagine declaring a vector v, starts off empty, then we call pushback, which adds this integer 1 to the back of our vector, and now we've also incremented the size. When we push back and we pass in 4, we add 4 to the back, and now our size is 2. We push back 3, now we've got 3 at the back, and our size is 3. So we already saw how to compute the average temperature, but let's say we wanted to compute the median temperature. So on this slide, they're showing one sorting function that comes from this library here, this header here. We will actually show the sort function that comes from the algorithms library. So let's Google that. Maybe here. So we will include the header algorithm, and this includes, let's see if we can find sort. So this includes the sort function, and it's going to need to take in 2 iterators, so one for the start and one that we want to sort. So we might just want to sort one portion of our vector, say, but so we can say where we want to start and where we want to end. So let's just see an example. So say we did want to compute the median after what we've done here. We want to compute the median temperature. So the median, if we were to sort them, would be in the middle. So first we need to sort the vector, and then we need to print the middle element, right? So if we do, go up here and we include algorithm, header to use sort function, now we have available to us, we can say sort, and so we need to pass in an iterator for the front of our vector and an iterator for the back of our vector. So let's go back to the slides, and if we go, so we might think to ourselves, oh, let's use this front and back method, but these actually give us the actual first element and last element. We want an iterator that's going to start at the front and an iterator that's going to start at the back. And so if we didn't know what those were, we could take a look at the documentation or the tutorials point documentation for this, for our vector class. So we start to see some things about iterators, but maybe I could search iterator and see if I find something that's going to help me. And here, begin is in fact exactly the method that I'm going to want, and then it's going to be end is going to be the iterator pointing to the past the end element, I guess is what it says. But we can also see that in the slides. Where was it? That they're going to call begin and end here. So let's do that. So we need temps.begin and temps.end, and we would need a semicolon there. So that should sort it. And then let's print the middle element. So I use my C++ syntax for printing, and I'm going to say median temperature is, and then, so now if I want the middle element, I can use my .size method, and if I think about just dividing that by 2, so it'll just perform integer division, so I'll get the floor. So say I had 5 and I divided 5 by 2, that would be 2.5, but it would then just be set to 2. And that would be good, because if our indices start at 0, which they do, if I had 5, 2 would get me the middle element. So I want temps, and then I can use the brackets like we saw above here on line 21. We can use the angle brackets. I could also use at and pass in, maybe I'll just do that to show that. So I can pass in my temps.size, and I said I wanted to divide it by 2. And then we can end the line. We could use endl, endl, or we can use the new line character, so maybe we'll just do that. And then now let's make, and then maybe let's do something that's definitely not sorted, but just prove that we get the right median. So I'm just going to say 30, 20, 50, 40, 10. So I know the median should be 30 because 20 and 10 and 20 are less than 30, and 40 and 50 are greater than 30, so the median should be 30. And now I'll do my Control D, and then I got the correct median. So another thing that I wanted to show is that, so we already saw a for loop like this, right? Let's go back to our, so here we saw we used .size to have a max how far we want to go in our for loop, but there's actually a more concise and more readable way to loop over a vector, and this is called a range for loop. So let's say print elements of array using a range for loop. So the syntax here is, again, we use for, but we're going to say the type of the things in our vector. So for us, it's a double. And then we're going to need to just give a name, because we're going to go through each one and we're going to get the double there. So I'm just going to call it T. Then we say colon. So it's kind of like for every double T in, and then temps is my vector. And now I want to do something. And what I want to do is I want to print out that value. So it's just going to be T, and then I'm going to put a space. And then maybe I'll put end of line so that we don't run up against our output's nicer. So let's try that out. And then maybe we do our same thing we did before. We can check our sorting. Oops, I guess I didn't quite manage it, but that's okay. So here it looks like we did successfully print. So that range for loop can be really nice and concise if you need to iterate over the elements of an array. Next, we will just see an example of reading in strings to a vector. So this will be really helpful to you for the lab 5, where you're going to, at least the way that I would solve it, is you're going to want a vector that holds strings as part of your solution. So we have, let's see, let's get rid of what we've been doing with our vectors, and let's copy from public examples C++ and computations. I think we have a words.cpp. And then there's also in here a words_in.txt that might be helpful to us. So let's take a look at words.cpp. So we've got, oh, we even sort our words in here. That's nice. So we're including the headers that we've seen before, and now we can see that we've got a vector of strings, and similar to the last program, we are just looping until we get something that is either, I guess, we could either put in quit, so we've got our logical AND here that's saying S should not be quit, and also S needs to be something that we can read in as a string. And then we use pushback to add S to the end of our vector. Then we call sort, and then here this is just going to print out all those words, and one on each line. And here we've got our range for syntax again. So let's try this out. Oops. So I could just make it and then run it, and then I could enter my words on the command line, aardvark in llama, and then I could say quit, and now it just ordered them for me. I can also use my file redirection, or not redirection, file redirection, to put in that words_in.txt, and now we see that those are ordered. And so the rest of the slides here give an example of how we could eliminate duplicates, but I'm going to leave that to you if you want to look on your own. Sorry, I'm like going weird places. So if you want to take a look at this, there is an example solution here, and so you can do that on your own time, but since we don't need that for the lab, I'm making that optional.